Hi everyone, good afternoon. Thank you for joining the session. I am Riya Joshi. I work as a data scientist at Microsoft, and today we are going to talk about how to fine-tune LLMs. So this is what the agenda is going to look like. We are going to answer some questions, some very basic, some not so basic. We'll start with what are LLMs, why do we need LLMs, how do we use LLMs, and then I'll show you a demo on fine-tuning. So let's start with what are LLMs. Though most of you must be aware of all this, but let's start with the background. So at the top of the funnel, it starts with artificial intelligence, which is basically the computer science discipline that aims to create machines that can solve tasks at par human performance. There's a new field of artificial intelligence that's been popping up, which is called artificial general intelligence. You must have heard some of the top CEOs talking about that. So artificial general intelligence is a part of artificial intelligence where the machines tend to perform tasks like humans without minimum intervention. We are very far away from AGI, so relax. None of your jobs are being taken away as of now. But yeah, LLMs do make us a step forward to AGI. Then part of artificial intelligence is machine learning. All of you must be aware of it, where we try to train, model, show some data to it and hope that it is able to capture the patterns and then replicate the patterns on unseen data. Then comes neural networks, which are type of machine learning models, and they just replicate similar type of functioning as it happens in our brains. How neurons connect to each other and how they pass information. Deep learning are basically neural networks which are very, very long. They have lots of hidden layers. Now because of this depth, they are able to capture lots of intrinsic patterns from the data. So that really, really helps us to learn more and more about the data and thus perform better. Generative AI is type of AI that are based on this deep learning paradigm, and here we just generate something. It can be text, it can be audio, video, images, anything. LLMs are just part of those generative AI models where we focus on generating text. Here, today in this talk, we are going to talk mostly about LLMs. So let's start with something very fundamental. What is the LLM architecture? So LLMs are trained on huge deep learning models, which are basically, they contain lots and lots, billions of parameters. Okay, so they are based on something very, very important in NLP, that is the breakthrough in NLP called transformer architecture, and they use some sort of mechanism called self-attention. So in very simple words, it means that it just helps LLM understand language and context much better than any other models. If you feel you do not understand any of the words that I have just talked about, you can go to this link. Last year in this very session, I talked about all these concepts in detail, so it can help you. Also, LLMs are trained on vast amount of data, vast amount for months on very expensive compute. Okay, so long story short, LLMs can learn and understand and create languages very, very easily. Okay. So this chart just shows how LLMs have evolved over past few years. Okay. So as you can see, before 2022, models were very small, which are also called PLMs now, like preliminary language model. For example, very famous BERT was just a few thousand parameters. But now LLMs are becoming bigger and bigger. There are billions of parameters. But in very near future, smaller versions of these big LLMs have become very prominent, because we realize that only prompting is not going to solve our use case. So that is why Mistral, Llama, Phi3, they are still big. They are 8 billion parameters, but they are still smaller than 175 billion LLM models. And the best case is we can fine-tune them. We can make them work for our use case. But why LLMs? So I don't think so I need to tell anyone about LLMs here, that what is their use case. We all are very aware. They are like omnipresent. They are being integrated by every tech company in every possible product. These are just some of the use cases where we see LLMs. So main important thing, how do we use LLMs as data scientists? First thing is zero-shot prompting. which means we are just telling the LLM what do we want. We just give it a task. For example, here is a example. We just ask the LLM, okay, give a sentiment to this particular text. Okay, this is how most of us interact with consumer-based LLMs. Okay, for example, chatbots or any search-based LLMs. But they are not always the best. Okay, sometimes tasks can be very complicated, and just giving the prompt might not be helpful. In that case comes few short learning, where not only we tell the LLM what to do, we also give it some demonstration of how to do it. For example, here in this prompt, first we give an example that, okay, this is the word, and this is how you use the word in a sentence. And then we ask the LLM to replicate the same thing when we ask questions. Now they are good enough, right? But they are not good enough in the cases where we have proprietary data. For example, company-specific data or data that is not openly available. In that case, LLMs will not work very well. In that case, we will need something called domain adaptation. Domain adaptation means to actually make LLMs work on your data. So as you know, LLMs have been fine-tuned majorly on open source data that is easily available over the internet. But in some cases, they understand language well, they can create sentences very well. But there will be cases where it will not be able to answer because it will not have enough context or background knowledge. For example, if you want to build a chatbot on patient's history data for a hospital. Now, patient data is very confidential. You cannot openly access it, right? So in that case, generic LLMs will not be able to give you the correct answers. And in most cases, they will hallucinate. That is, make up the information. Then also, for example, you have very company-specific use case and company-specific data, which is very particular to your company and not available anywhere. In that case, if you want to build any sort of LLM solutions, generic LLMs might not work. You might need to do something more so that you can adapt LLMs to your particular company use case. Third case is some tasks are very difficult for LLMs. Okay, in that case, it is always a good idea to give some instructions in some sort of fine-tuning to LLM, and then only they can work well in those cases. So let's talk briefly about how can we adapt LLMs to our use case. First thing is domain-specific pre-training. We just start from the scratch again. Okay, we teach LLM language again from the starting on our proprietary data set. Okay, as you can imagine, this is very, very expensive. You need to be either a billionaire or have lots of money and resources to train that. Only very big companies are able to do that right now. Second is domain-specific fine-tuning. Now this is something that is under our control, and with few GPUs you might be able to achieve it. Here what we do is, we already take the pre-trained LLM which knows language well and just train it on some sort of our specific kind of data set on the task that we want to solve it. It can be classification task, it can be name entity, it can be anything, or text summarization, whatever. This is much cost effective than the other one and attainable. The third and very, very prominent thing that has become very popular, and we are not going to talk much about in this talk, is retriever augmented generation. This concept came into limelight majorly after LLMs. Here no training is required. Here you just add an additional external knowledge database to your LLM, and whenever the LLM is trying to answer something, it refers that database and only answers questions based on the information from that database. Where it can be really useful is, for example, if you are trying to build, if you're working in a big firm, okay, you have a lot of engineering documentation, you want to build an FAQ that answers, those questions for your engineers. In that case, the documentation just keeps on updating every day. It will be very difficult to fine-tune the model again and again, even if you do monthly, because then there will be a lag in the information. In that case, you can just attach an external knowledge database. It can be an Elasticsearch DB or anything like that. And then your model will, when it will be creating answers, it will refer to that data source and only generate answers from that data source. So it also prevents hallucination. If you want to learn more about it, I have written a 3-part series along with a demo. You can check this out later. let's talk about the main star of the show, fine-tuning. So fine-tuning means already using the mighty LLM for our particular use case. There are two types of fine-tuning. First is full fine-tuning. We just fine-tune all the billions of parameters of the model. Okay. Now, as you can imagine, this can be very, very expensive. At the same time, there is also one more problem called catastrophic forgetting. What it means is that if you fine-tune or update, fine-tune means to update all the parameters, then the LLM can forget whatever it knows. Okay, it can forget or lose its ability to even construct coherent sentences. And that is something we really don't want. So, the community came up with a more intelligent way of fine-tuning, which is very popular with LLMs, which is called PEFT, or Parameter Efficient Fine-Tuning. Here, we very smartly do not update all the parameters of LLM. Rather, we inject new parameters, very small parameters, into the LLM layers and just update those parameters. At the same time, we just freeze the original model parameters as is. So we are already preserving the knowledge that LLMs already have, and for updating the new parameters or to update it to new tasks, we just update the new parameters. So we'll talk a little bit in detail about that. So adapters are one of the most prominent ways of achieving PEFT or parameter efficient fine-tuning. Here what happens is, so this is a very standard example of how a transformer layer looks like. In case of adapters, we just inject some additional parameters in between the layers. Okay, we keep all the other transformer layers frozen and just update these particular parameters. Now these parameters are just a fraction of the original parameters. So we achieve two things. First of all, we just fine-tune very small number of parameters, so we are saving on compute power a lot. At the same time, we are just freezing the original parameters, so we are not, doing anything to originally acquired knowledge of the LLMs. So the only problem with the old-fashioned adapters were they were added sequentially in the layers of transformers, so they were sort of adding some sort of inferential latency because they depend on each other. The new form of adapters which are prominently used with LLMs are LoRa, which is low rank adaptation. So the concept of LoRa is very similar, very simple. So we just we have a big matrix, weight matrices. We divide that big matrices into lower rank matrices. Now what happens is these two lower rank matrices are equivalent to the big matrix, but the number of parameters reduce a lot. Okay, so here if you can see the number of when we break them into lower rank matrix of rank 1, the number of parameters become 25 times lesser. So that means very easy and comparatively less expensive to train. And then what we do is, we already have the layers and the parameters of our model that we'll keep it as is. We just inject these extra parameters and only update those while we are fine-tuning for a task. And the good thing is, if you want to fine-tune our LLM on multiple tasks, we can add multiple adapters, at the same time keeping our base model as is. QLoRa is similar to LoRa, except it's a quantized version. Instead of using floating point 32-bit, we use int4. So let's talk about a demo. Here I have chosen a relatively easy to follow use case, which is binary classification to detect sarcasm. It is easy to follow, but it is also not very straightforward because sarcasm detection, only 84% human accuracy is there to detect sarcasm. Okay, so let's see how our model performs. I'm going to compare two approaches. One is few-shot prompting, where I'm going to give some examples to the model and ask it to replicate on the unseen data. And at the same time, I'm going to fine-tune on Mistral 7 billion model. If you want the full code, you can access it on the Collab notebook from here. I think the team will share the PPT later with you. Remember, if you need to run the fine-tuning code again, then you need at least 1 GB. So this is how the data looks like. So the data point has a parent comment. So it is basically a political data set that has Reddit sarcastic comments. Okay, And the comment will be some reply to that parent comment, and you just want to predict whether it's sarcastic or not. Then we load the model. I'm using 7 Mistral because when I created this demo, Llama 3 was not out yet, and Mistral 7 billion was still the best performing small models. You can use any model. And then we just load it in a quantized configuration because I want to make it work on one GPU. This is how an example of a prompt looks like. Okay. So here I'm giving the model the guideline of what type of task it needs to perform. At the same time, I'm also giving it some examples, okay, of what a sarcastic comment look like. And then I also distinguish the guidelines with examples very clearly with pound tokens so that model is able to understand that what is the guidelines, what are the examples. It is very easy for LLMs to hallucinate, and when you will work with it, you will realize that prompts can be broken very easily. This is a very boilerplate code of the trainer class where I just set up the fine-tuning hyperparameters. Then I also set up LoRa config. You can change the rank, you can play around with the parameters. And next, this is the evaluation difference. So here on the left side, you will see few-shot prompting. Okay, the model just attains an accuracy of 45%. It is definitely not doing good at all. Okay, and it not only generates the sarcasm versus non-sarcasm class, it also generates something random, garbage, hallucination values, and that is what I have mapped to the none category. Okay, you can see an example below here that it's not able to generate or comprehend text very well. Whereas when I fine-tune the model, and I have fine-tuned only on 1000 data points and evaluated on 100 data points, the performance increases a lot. I'm able to attain an accuracy of 80%, and the model doesn't hallucinate. So even in a very simpler task like binary classification, LLMs might not be able to perform that well if the task is not that straightforward. So the conclusion is, yes, binary classification is relatively an easier task, especially for mighty models like LLMs, but sarcasm detection is not that straightforward even for humans. We have only a human accuracy of 84%. So few-shot models are not able to do that well. They only attain an accuracy of 45%. With fine-tuning, we can get an accuracy of 80%, which is good enough, and we do not get hallucinations as well. If you want to use the same code or same approach, it will work for any other task as well using the LLMs. So yeah, thank you. If you want to reach out to me, you can reach out to me on LinkedIn. I think
Hi Riya, what kind of accuracy difference have you observed when you configure an adapter versus you fine-tune the LLM?
We are not using adapters nowadays, so original adapters. Okay, so major type of adapters that are used in LLMs nowadays are. So I didn't try with any other adapters because the major adapters that work with LLMs are LoRa or Q.
But like even with LoRa, when you are just adding the adapter versus you are fine-tuning the whole LLM, what's the accuracy difference?
I couldn't fine-tune the whole LLM because I don't have that sort of money. Okay.
Okay, yeah, it works. Great, thank you. Great presentation. What's the cost difference between few-shot prompting and fine-tuning? So the prompting would just be token exchange, whereas fine-tuning, like you said, none of us are billionaires, so we're just gonna do PEFT, but must be some cost associated with it.
Yes, definitely. So for fine-tuning, you will definitely need a GPU. Okay. For prompting, you might be able to do it on a CPU as well. I haven't tried it with Mistral, but I have tried that with Llama 2. Okay, so I was able to inference it just with fine-tuning on a CPU. So that's one of the major differences of training. You need the compute. For training, you definitely need the compute, and GPU is not.
So Colab Pro is good enough for fine-tuning then?
Yes.
Okay.
So you talked of fine-tuning and RAG, two different approaches to adapt LLMs to a particular context.
Yes.
In a business scenario, how do you decide, what metrics do you look at to choose between the two approaches?
Yeah, that's a very good question. So RAG is basically, you do not require any form of training. What you need is an external data source which you can query. So in the case where your data source is changing again and again. For example, the example that I gave, that you have a query, you want to create a FAQ chatbot on documentation, and the documentation is updating daily. A daily new documentation is being modified or added. In that case, if you fine-tune the model once or even every month, it will not be updated, right? So wherever the information changes very fast, it is better to use RAG rather than fine-tune the model. Wherever you think the model is, okay, once you train, it's good for at least some time, a few months or a few years, then it's better to do fine-tune.
But does RAG come at a performance loss?
Not necessarily. Okay? Basically, they are used in two very different scenarios. Okay? For example, for binary classification or name entity recognition or text summarization, you might not use RAG. Okay? But you might use RAG where you want to prevent hallucination. Okay? You don't want to give any random answers. You want to base your model to give answers from a very fixed data source. In that case, RAG.
Thank you.
Hey, for like a reliable accuracy, how much data would you require to train this? Because like an internal wiki for a company may not be so large.
That's a good question, and that totally depends on the type of problem you're trying to solve. Some problems are inherently very difficult, so model might need more examples. Okay, the best. What I have tried in because I tried for pet projects on my own commodity hardware, I have always used 1,000 to 2,000 data points. Okay, but yeah, it can totally depend on type of problem you are trying to tackle, and the best way is maybe just first of all look into your what type of hardware do you have. If you're using a company specific and GPU and you have a lot of GPU, then go ahead, train it on large amount of data. It majorly depends on the money and all those things. At the same time, it's also worth it to exploring this thing as a parameter. Maybe if you start small, and if you think the model is not able to achieve that much performance, then increase the weights.
So, in this presentation, like you're talking about use Mistral 7B because Llama 3 just haven't come out. But if you're trying to actually build something and productionize it, like how do you deal with the fact that these models become obsolete fairly quickly?
That's a good question. That's actually a very good question. First of all, if I'm fine-tuning, I don't have many options. Maybe Llama, Mistral, some small anthropic models, right? So the best way is whatever you're building right now, whatever best you have, you start building on that. At the same time, you don't need LLMs. When they are evaluated on a very different criteria, not on a very general criteria. For example, how good the model can write code, or how good model can inference something. That is good in general scenario, but might not be useful in your particular scenario. For example, if I'm building a classifier, I'm more worried about the accuracy or F1 metric rather than how well the model is able to generate information. So if the model is doing good on your particular task and your company is happy, then it's fine. You can stick.
Thank you for the presentation, very helpful. I have a question about if you have, say, two tasks that are related to each other but not completely the same, would you fine-tune the model on both tasks at once, or would you kind of separate them into like two different, having this set of parameters for this one task and having another set of parameters for the other task?
So that, I would say that totally depends how close the tasks are. For example, if they're language-based tasks, for example, summarization, one is summarization and another is maybe paraphrasing. Okay? I would always suggest start with zero-shot prompting and few-shot prompting before fine-tuning. Because you never know sometimes, because these language models are strong at the end of the day, right? They might be able to do just as good, good enough. But if you have very niche tasks or proprietary data, then I would say always fine tune just on one task first. See how it performs. See if your other task is able to be absorbed in this model or not. And if not, then you can fine tune another.
We'll take the last question and then we'll wrap it up.
Hi, I have a quick question. So domain adaptation is known for suffering from the domain gap or domain distribution shifts.
Yeah.
How do you handle that in the practical setting?
That's actually a very good question, and that is why RAG has become very, very popular, because RAG just gives you the real-time information. So one thing is, even after fine-tuning, nobody's stopping you to add another external data source. That is just something, this is something very new industrial problem, so even everybody is trying to find different solutions. But this is one solution that I have seen people adopting is, if you feel that generic LLM is not able to do that good, fine-tune it, attain it to a decent position, and then you feel if your model is, needs constant adaptation or your data is changing so fast, you can add an external, basically a hybrid sort of solution.
Awesome. Thank you, everyone.
Thank you.